In this video, we'll introduce conjugate priors. Conjugate priors. Conjugate priors are extremely useful in the Bayesian setting because they allow us to get the posterior distribution on the parameters given the data in closed form. So they make life very much easier. And so what is a conjugate prior? Well, let's make a definition. A family F, I'll use this capital script F, a family F of distributions, and they're going to be prior distributions, so I'll say maybe prior here, prior distributions. P of theta, we usually write such distributions, P of theta, this is a shorthand, is conjugate to a likelihood, this is just some distribution on x given the data, or on the data given theta, conjugate to a likelihood, P of d given theta, if the resulting posterior, P of theta given the data is in F. So we have some family of distributions here, which I'll write, this would be like one of them. And we have chosen some, there's some likelihood, some distribution on the data given theta. And if when we compute the posterior under this model, right, of course this defines, if I choose one of these and I multiply it times this, then there's a joint distribution is defined. And so the posterior distribution is defined. And if that posterior distribution is also a member of this family, each of these is a distribution over theta, then we say that that family is conjugate to that likelihood. So let me give an example, since that may be a little bit abstract. Well, actually, I'm not going to give an explicit example in this video, but I'll mention a couple examples, and we'll look at them in more detail in another video. So some examples, just to mention some, the beta distribution is conjugate, we say is conjugate, well, I guess that's how I said it, conjugate to the Bernoulli. So if we had some sequence of x's that came from a Bernoulli distribution for some parameter theta, and we put a beta distribution on that parameter, then it would satisfy this condition. That's one example. Another example, there's lots of examples. Let's see. So another example is that a Gaussian is conjugate to a Gaussian for the mean. So this is for if we consider the mean of a Gaussian as a parameter, and we put a Gaussian distribution on that mean, then that's a conjugate prior. So I'm not going to work these out in detail, but we'll look at these. We'll see these in other videos. And in general, more general, then you can look up. There's lots of examples, and in fact, there's a very general result that any exponential family has a conjugate prior. So since exponential families are a very wide range, cover a very wide range of different distributions, then there's a very large number of distributions that have conjugate priors. So that's a wonderful, a beautiful fact. And in some sense, the converse also holds here. In some sense, any distribution with a conjugate prior is an exponential family under some conditions. So this is just the definition of conjugate priors, and I'll give you some examples in other videos where we'll look at this more explicitly.